Hello everyone. In this video, I'm going to explain you why the hell do we need machine learning for. So let's take the example of India. So we know that in India that we have the voting rights at age 18. So here I've just made a small data set which has names as a column, the age and whether the person is a voter or not. Now we know that in India greater than 18, age greater than 18 is a voter and less than 18 not. So see 18, so 1, 16, 0, 23, 1. So all over than 18 it's a 1 and less than 18 it's a 0. Now what if we plot this? So let's plot it. So here I've made a plot. Here this is the voter, the y-axis, and the age is the x-axis. See, for 18 I have a point here. For 16, which is here, is 0. And for say 23, 68, 79, here all these are there, and here for 15 and 10 we have here. So see, it automatically has a segregation. We know that there's something that differentiates this, which is the 18. Okay, now let's take a different condition. Suppose we have let us assume that we're in a hypothetical country and the age doesn't only depend on or is only not the factor for voting, but also maybe the height. Let's take it hypothetically. If we add a new column to it, which is height, then what will happen? So as we have seen that in the previous example, we have said that we can segregate with the logic that if someone is greater than or equals to 18, then the person is a voter, otherwise he's not. Now what happens if we live it? Now, as I said, in a hypothetical country, let's assume that the logic for a person to be voter is that the age needs to be greater than or equals to 18 and the height should be greater than 6 or anything else which is a non-voter. So I've just given some hypothetical values for the same people. See for the vote age 18 and the height 7, which follows this condition, it's a voter. So, and for the 16, 6, even if this person is a proper height, but because it's not 18 and it's not a voter, so 0. So in this way we have taken some data, and now what happens when we plot it? So now see, the voter and the non-voter is this y-axis, this plane, and the non-voter is the second plane. I hope I can explain. And this one is the height and this one is the age. So it's a 3D plot that I'm showing on a 2D space. Okay, so after we plot this, we'll see for some examples. So 18, so it's 18 and the height is 7, which is 7. 18 and 7 goes and plots here. And for the one, again this one, 68 and 8, the age is 68 and the height is 8. So it must be somewhere here. It's the extended plane. I don't have the space. So we know that voters will be plotted in this plane, and the non-voters will be plotted in this plane. See, these are all the people for like 16, 6 and 0. So 16, 6, 16 must be here and 6 must be here. So the person is here. So this all the same 0, the non-voters are in this plane. So in this way, we can again segregate the two components of voters and non-voters. Now, what happens if we add another column? As I said, it's a hypothetical country. You can add as many columns as we want. What happens if we add another column? If we add a column, maybe weight. Maybe there is a logic for the weight. If the weight is not above the certain threshold, maybe the person is not a voter. So then in that case, what will happen? We will have to extend this from a 3D plot to a 4D plot, which essentially is that we will have to plot it in this way also, or maybe the x, y, z, and a second plot, this one, not this one. So now when it was 3D plot, it was easy to visualize, but what now? When it's a 4D plot, human eyes cannot decipher because we have the capability to see up to 3D. So how can we decipher it? That is exactly where the machine learning comes into play. If human beings had the power to see in n number of dimensions, we never needed machine learning. We would just plot it in a graph and then we look at it from a certain angle and then we'll get it. But that is where machine learning comes into play. Machine learning takes all the data and plots it into the n number of dimensions and then it tries to segregate it. If it's a regression problem, then it segregates it via the context of finding the least errors, finding the least sum of errors, and like that. So suppose, so if there's a n number of plots and the data are here and here, so it will plot it will measure the distance from here, the error, and then sum it and see which is the highest one, and this way the line will adjust itself. This is the reason that we need machine learning for. Had we the ability to visualize everything in n dimensions, suppose we had the power of visualizing in maybe 10 dimensions, 12 dimensions, then maybe we could work with 10 and 12 data columns in a data set, and we will have not any problem because we can visualize it. This is where machine learning comes into play.